In section 4.4, which is called improving the wave shape, I'm going to break it down this section into several different videos. I think it will be better just to do that this way. It gets a little, there's a lot of detail with this, and you know, we're going to walk through it, and it's important to get the detail, but let's break it down and make it a little easier to follow by creating several videos. Okay, imagine if you will that you have a DC voltage, and that DC voltage looks like this, okay? And as you can envision, you know, this isn't going to work. You know, we couldn't have a DC voltage that would rise up to this peak value and then fall down to this and rise up to this and fall down to that. Imagine, say, like a car headlights or something. You know, could you imagine that situation where you had those peaks and valleys, and you know the lights would just kind of be flashing on and off, and you know that just wouldn't work. You know, so we couldn't have that. So what we need to do, is we need to flatten this DC curve out. You know, how can we do that? How can we flatten that curve so it doesn't have these extreme peaks and valleys? Well, the way that we do that, one way, a combination of things that we do, is that we add coils. So in our original DC generator that we had here, you know, we basically had, you know, two coil sides, you know, rotating through. And so what we're going to do here, we've got the same magnetic field, and we could also, we'll see in a minute, we can add magnetic poles too. But what we're doing here is we're adding coils, okay? And so we're going to kind of try to walk through this. It looks kind of complicated. You know, there's a lot going on with this. And so I kind of want to walk you through, you know, what is actually happening with this, and see if I can show you, you know, how this thing operates and how we're able to flatten this DC curve out, okay? Let's pause just a second. By adding coils to the construction of the DC generator, we can get to this goal that we need approximately 5% what's called ripple, which ripple is, you know, if you, a way that's non-mathematical to think about it is, you know, the amount of variation from the high to the low. You know, how much variation does it have? I mean, you can actually calculate ripple voltage. It's the RMS voltage divided by the DC, and you know, you can actually calculate the percent ripple that you have in a particular voltage. But you know, we don't need to get into that detail. But what we're looking at is, you know, here's a coil here. Oops. Here's a coil. Here's a coil. Here's a coil. And here's a coil. All right. So what we're doing now, instead of passing, you know, that original coil through the magnetic field, we've added coils to this. All right, and what that's going to allow us to do, and I'm going to walk you through the different parts of this in the next video, but what that allows us to do is to take, you know, this DC voltage here, and by adding coils, I can flatten it out so that it's more uniform, and so that the output DC voltage looks more like that. And then I can even do additional things to flatten that out even more, okay? So anyway, that's what our goal is here, and that's what we're trying to do in section 4.4. We're trying to flatten that DC voltage.